next we will try to build a smart factory model using the processing time and setup times those were obtained during the validation of the experiments, those were conducted to obtain the data, and the data was analyzed or optimized with respect to green, and we had these times. So, these times were now put as input in this scenario. So, we chose drilling, milling, drilling and grinding in a sequence. So, this was termed as line 1 and this is my line 2. So, line 1 has 1, 2, 3, 4 processes, line 2 has 1 and 2 processes here. So, as inspection, both of the inspection are manual inspection kind of thing, and also the setup times are manual. So, triangular distribution was chosen here for setup times and also for the inspections. And for the other the variability is less, the processes normal distribution was chosen. But in micro machining what was seen, that this micro machining actually we did micro EDG, micro wire ED machining. This was actually micro EDG. In this case the variability was too high. So, here also the triangle distribution was chosen. So, next important thing was to select the pool of the workers. So, various scenarios were developed for line 1 and line 2. For instance, different work pools were chosen. Single work pool was chosen to, and the workers were considered to have equivalent skills to work on all kinds of machines. So, no skill difference was considered. And in the other scenario, the separate work pool was chosen, in which the workers who work on micro machining, they were separate, that is they were more skilled workers in comparison to the workers who work on milling, drilling and grinding. So, this is scenario where separate work pools, this is work pool 2, this is work pool 1. So, we have here these brokers, broker 1 and broker 2 for these two work pools here. These charts we have seen the details that how the charts are being plotted. This is again for line 1 and line 2. One thing we have here is experiment manager. Now, what does experiment manager do? So, when we have to run a simulation, we need to define the observation per experiment is 50. For each experiment 50 observations would be run, and we also define the experiments here. So, in this case 25 experiments were chosen, a total 25 experiments, and this is milling processing time, this is setup time, drilling processing time. This time has come by itself. In this case, for example, normal time was given, and in case of inspection, this is the inspection, the time given was a triangle distribution. So, these input variables were first defined, that is milling processing time, milling setup time, drilling processing time, setup time, grinding processing and setup time, inspection 1. This is my line 1. Then we have line 2, in which micro EDM processing time, micro EDM, micro wire EDM setup time and inspection 2. This is my line 2. After defining these values, we define the experiments, these experiments. Now, output values were also defined, that is the time for which the machines or the workers are working, the time for which they are failed, throughput of line 1 and throughput of line 2. These were the output factors, or these were the output factors, those were selected here. So, After running this simulation, we can start the simulation here. So, simulation has started. So, you can see that time is coming here at the bottom left corner. So, simulation is running on. So, total number of observations for each experiment, that is for 25 experiments, 50 observation would run. For each experiment, 50 observation would be run. It now, like example, for instance, here experiment number 19, 1 to 50 observation is being run and results would be obtained. We will see the results, the plot of the results as well. So, we have this report here. So, it is giving a dialog box, the experiment run is finished, the running time was this much. So, we have obtained a report here, this is report, that is chart 1. It is say that this the processes are not named here, this is single process 1, this is M stage is single process and single process 1. It is working for this much percentage of time and it is being set up time as it is put here, being set up for this much time, and this is the waiting time, this is blocked time, and for this much time percentage of time it is failed. The failure here is because we chose the normal distribution and we have put 5% failure rate here as well. So, the results could be obtained here as well. So, this is the throughput for line 1, throughput for line 2 for each experiment after running 50 simulations, 50 runs. So, let us see the detailed results here. So, in this case, if I say, let me see the throughput only. For the throughput line 1, this is for the 50 observation here. For only 50 observation for experiment number 1, that is there total 21 experiment, 25 sorry, there are total 25 experiments and each experiment has 50 observations. So, here for experiment number 1, the 50 observation had average throughput of 177 and this was the standard deviation, this was the minimum and maximum throughput, left and right interval bound are also given. This is only for one experiment and for all the 25 experiments these observations are given. So, this is the detailed result. So, the average throughput of the day would be the average of these 25 experiments. Now, this is our simulation of the scenario when workplace or I would say worker pool are separate. So, let us see the results when this worker pool is not separate. In this kind of scenario, we have a single worker pool with each worker having similar skill set to work on the micro machining as well as on the conventional or CNC machining. In this case, grinding is a conventional machining only, like we observed in our laboratory demonstration. This is a CNC machine. This is a CNC machine which was MCO Concept Mill 250. This is a micro machining, that is this is DT110 micro tools machine. Micro tools. This is a company, this is the machine model, this is the name of the company which is Singapore based. So, in this scenario, what are the results? So, one of the important thing here is to select the pool of workers as it impacts the total cost as well as productivity. The machine failure rate here was kept as 5%, that is, this is failure rate, that is machines are 95% reliable. So, this failure rate could be put in here. So, if you see the failures, so when I open this machine 1, if I see the failures, I have put that my failure 95% of availability is there. So, this is 95% reliable. So, this failure rate is kept here. Okay. So, this is my machine failure rate, and the worker travel speed here is 80 meters per minute, that is given by ILO, 80 meters per minute as recommended by International Labour Organization. That is also shortly termed as ILO. So, simulation was replicated 10 times for 10 different random seeds here, and this figure depicts the mean productivity against the number of workers. The mean productivity here in this case is about 172. This value is actually 170 here. I will put it clearly 170. So, in case of line 2, this average value was 14.4. So, this cannot be the number of parts. So, it is actually 14 here only. So, to choose the work pool, the first starting scenario was 1 worker per activity, that is there are total 6 activities and 6 workers were chosen. 1 worker per activities was the starting point, and it was found that the similar throughput is possible with 4 workers as well. So, when we choose 4 workers, the throughput is this much, and when we choose 6 workers, the throughput is this much. So, only this much increase is there, this small increase. Small increase by instituting 2 more workers. So, however, 5 workers is also one of the alternative, but this only results in the small increase is 4.7% of increase in productivity by using 5 workers, 4.7% using 5 workers, and in this case it was 7.1% in line 2. This was using 5 workers. So, this increase was small. So, with 4 workers for 2 lines combined, further experiments were conducted. So, the number of workers were fixed to be 4. So, you can see how our simulation is helping us. It has helped us to decide the number of workers for the present scenario. So, number of workers selected here are 4. Then with these 4 workers, 25 experiments were run, and each experiment had 50 replications. that is what we saw as observations, 50 observations in our software. So, line 1 throughput, this is throughput of line 1 and line 2 throughput. So, the line 1 throughput exhibited little variability, you can see the variability is less in comparison to line 2, and the line 2 had large variability, because the reason for this can be attributed to this smaller value. This value is small. So, this is the number, this value, the maximum value here that is obtained is maybe 18. So, because of the small value, small average value, so this variability is high here. It can be noted that the average green throughput of line 1 is about 170 units, and for line 2 the average throughput is about 14 units. Now, here the standard deviation in line 1 was 4.5 units, which is 2.5% of the mean, and in this case in line 2 the standard deviation was 1.5 units, which is 10.7% of the mean. Since line 2 is exclusively micro WEDG process which has higher variability, the throughput also exhibits similar variability. So, that means our simulation results are quite able to represent the realistic situation. So, this is also one way of representing the total 93.23 percentage of area is under my normal curve, and these are the standard deviations here. This is for line 1 and this is for line 2 here. So, also we can see the utilization charts here, the resource utilization charts. So, in this case you can see that the first machining process, that is milling, that is occupied for about 45% of the time, and for this is my setup time. The point of interest here is the blockage. So, this is my blocking. So, this is my blocking, or better I would say block time. So, the processing and setup times for the machines averaged as per the input distribution provided in the simulation model. The idle time for workers varied from this idle time from workers varied from 1 to 6%. This is idle time. And for the remaining of the time, they were either operating machine, doing the setup, or they were moving, they were en route to the job. So, it is evident that milling machine is blocked here. If I say specifically, it was blocked for 28 percentage of time due to larger processing time of the immediate successor. This drilling time was higher than the milling time. So, this can also be reduced by inducing a buffer over here. If we induce a buffer here, this could help. However, this would not affect our green throughput. So, here the throughput which we are getting is a green throughput, because each of these processes are performing, are operating at their optimized or their green settings. Not the inspection, but milling, drilling, grinding and micro machining are operating at their green settings. So, this is my smart factory. So, in this case you can see this time, drilling time was a bit higher than, or I could say the difference was quite high in comparison to milling time. That is why, see the difference. So, that is why this blocking happened, So, I would like to conclude here. A unit manufacturing process was studied by doing live experiments. The experimental data was statistically analyzed to identify the significant factors influencing the greenness here. ABC simulation was used to determine the optimum settings of the process parameters, and a complete hypothetical flow shop here was developed, was modeled using discrete event simulation. So, I used a hypothetical flow shop only. So, in the actual or realistic scenario, we can even use the realistic data, and this kind of approach can be used to obtain a green factory. So, with this I would like to conclude this course from my side, wherein we have started from the very basic introduction to manufacturing systems, and we have concluded to develop a smart factory. So, in the whole process we have gone through sustainability framework, life cycle assessment, various kind of sustainability systems and the elements of sustainability systems, the kinds of layout and the simulation processes, all this we have gone through. So, please come up with some good questions in the forum, so as we continue this learning process, and it was a good experience to be in this course. So, with this I would like to pay my heartiest thanks to all of you. Thank you.